In today's video, we're going to be discussing a high-yield MCAT physics topic that relates seesaws to wrenches, specifically torque. Now, unfortunately, physics tends to get a bad rep of being a difficult and complex subject, and that's because, unfortunately, some professors will jump straight to the math before explaining the underlying concepts in an intuitive to understand way, like behind the equations. And I found that for the MCAT, let's face it, there are hundreds of equations you need to know. And if you're going to rely on rote memorization, it's only going to get you so far. So my goal from these videos is to explain the underlying concepts behind the equations and relate the variables to one another so that you don't have to rely too much on memorization. You'll see what I mean by this as we go over first deriving the torque equation and then a specific example related to torque. So let's get started with deriving the torque equation using an intuitive scenario that we all encounter on a daily basis. All right, so in order to derive the torque equation, we're going to use the motion of opening or closing this cabinet right here. So torque is nothing but the rotational force about a pivot point. So our pivot point over here will be the cabinet hinges, and the rotation is the process of closing this door over here. So what are the factors that are going to impact how efficiently I can close this cabinet? First of all, let's consider force, obviously. If I push with a higher force, the rotational movement is going to be greater, so torque is going to be greater. So far we know that torque equals force, but of course there's going to be other variables, and because both of these are in the numerator and they're on opposite sides of the equal sign, as one goes up, the other one also goes up, and that's consistent what we saw in our scenario over there. All right, let's consider the next variable. All right, so the next variable that can contribute to the rotational force or the torque of closing this cabinet is how far you are from this fulcrum, how far you are from the hinges. So if I'm pushing right here, it's very easy for me to close it, as you can see. But if I'm pushing all the way like at this level right here, it becomes harder. I need to apply more force. Now, from that, you can infer that the greater the distance away from the fulcrum, the higher the torque. So we can add distance to our equation right here. And once again, distance is in the numerator because the higher the distance you are from the fulcrum, the higher your torque. Now, there is technically one more variable that can impact torque. Let's take a look at it. The final variable may not be as intuitive as the other two, but it's the angle with which you push against the door. So if I push at an angle of 90 degrees, so perpendicular to the door, I'm sort of maximizing the force that I'm pushing with. But if I push at like a 60-degree angle or a 30-degree angle, the smaller that angle gets, the more force I have to apply. So the bigger the angle, the greater the torque. The way we factor in the angle is by taking sine theta, or the sine of the angle. If the angle were equal to 0, then the sine of 0 is just 0, and therefore your entire torque is 0 because you're multiplying these numbers by 0. And that makes sense because think about what we're doing here. If I'm pushing this wrench in this direction, that is a 90-degree angle against the wrench. So you will maximize your torque because the sine of 90 equals 1. Whereas if I push at a 0-degree angle, so like this, think about it, no rotation about this bolt over here will occur, okay? And so that's the idea. And of course, if you're like in between an angle of 0 to 90, as you increase the angle, you're increasing your sine. So this would be a sine, this would be equal to 0.5, this would be equal to 0.86. All right, so now that you have the intuitive understanding of the torque equation and the variables involved in it, let's take a real MCAT example that can show up on test day. All right, so the question reads, a uniform horizontal beam is balanced on a pivot at its center as shown in the diagram below. Assume the beam is massless and the acceleration due to gravity is 10 meters per second square. What is the magnitude of the force required to balance the beam? So this is the beam we have over here. Notice at a distance d, we have a block that's 2 kilograms hanging down here. And then also at a distance of d, so these distances are equal to one another, we have this force being applied at a 30-degree angle. Now they're asking us what specific force would balance this beam so that it's not pivoting this way or this way. All right, so the first step to solve this equation is to recognize that you actually have two torques. You have the torque on this side and on this side. So we'll call this torque the torque on the right and this one the torque on the left. Now, why did I set them equal to each other? Well, because the beam, again, as we mentioned earlier, is balanced. So in order for the beam to be balanced, both torques, the torques on either side, have to be equal to one another. So now let's consider what factors are impacting the torque on each side. Of course, on the right side, we have the torque due to this block, and on the left side, we have the torque due to the force. So first, let's calculate the torque due to the block. All right, so of course, the torque is going to equal F times D times sine theta. Because we don't have the force here, we need to calculate that. So mass times gravity, or mass times acceleration to get the force. So we have 2 for the mass, 10 for the acceleration due to gravity. The distance, we don't know that, so I'm going to keep it as d for now. And then finally, sine 90. So the answer here is 20d, right? Because sine 90 is equal to 1. All right, so now let's move on to the left-sided torque. Okay, so again, the left-sided torque, FD times sine theta. Theta here is 30, so FD sine 30. I don't know F or D, so I'm going to leave them as is. Sine 30 is 0.5. Memorize that because we don't get a calculator on the MCAT. So now let's set these equal to one another because recall TR equals TL. So therefore 20D, which is what TR is, will equal FD 0.5, which is what TL is. As you can see, I was able to cross D out on both sides, and that's because, as we mentioned earlier, the distance on this side is equal to the distance on this side. So therefore, you can just cross them out. So you're left with 20 equals 0.5 times the force. So now very straightforward algebra, just multiply by 2 on both sides. And so your force equals 40, right? Because 2 times 0.5 is 1, and 2 times 20 is 40. So the correct answer is answer choice C. All right, if you found this video helpful, be sure to like and subscribe to stay up to date with all of my content. Also, share this video with your friends. It really helps the channel grow, and I would really appreciate it. Let me know in the comment section what topic you want me to cover next.